This is my favorite hands-on example of implementing a chatbot. Everybody needs a chatbot. So building a chatbot involves natural language processing techniques and matching learning models. Below is a simplified step-by-step guide. Let's go over these steps one at a time. First one is data collection and pre-processing. In this, first we do is a data selection. Choose a data set suitable for training a chatbot. Common data sets include conversational data from chat logs, forums, or customer support interactions. Next, data pre-processing. Pre-process the text data by tokenizing, cleaning, and vectorizing it. Remove punctuation, special characters, and stop words. Convert text into numerical vectors using techniques like word embedding, example word to vec or glove. Step 2 is building the sequence to sequence model. First, model architecture. Design a sequence to sequence model for chatbot responses. The model typically consists of an encoder-decoder architecture with recurrent neural networks RNNs or transformer layers. Model definition. Define the sequence to sequence model architecture using TensorFlow's Keras API. Implement encoder and decoder components with appropriate layers like LSTM, GRU, or attention mechanisms. Step 3 is model training. Data preparation. Prepare the conversational data to input-output pairs suitable for training the sequence to sequence model. Compile the model. Compile the sequence to sequence model by specifying the loss function, optimizer, and evaluation metrics. Training. Train the sequence to sequence model on the training dataset using TensorFlow's fit function. Monitor training progress and performance. Next step is model evaluation. Validation. Evaluate the trained model's performance on a validation dataset using metrics like BLEU score, perplexity, etc. Last step is chatbot interaction. User input. Accept user input or queries from the chat interface. Model interface. Process the user input through the trained sequence to sequence model to generate responses. Output. Display the generated response in user in a chat interface. Here is a code snippet of how to do this. So first, let's import TensorFlow. Next, we are importing input LSTM and dense layers from Keras layers. Then we are importing models from Keras models. Next, define the sequence to sequence model architecture. We'll create a variable called as latent dim and assign it value 256. Next is encoder inputs. We're going to call the input function and pass it shape of none and num encoder tokens. Next, we create an encoder variable, pass it LSTM with the latent dim that we created above, and return state equal to true. Next, we'll get the three different variables using the tuple function encoder. We get encoder output, state h, and state c by calling the encoder function and passing it the encoder inputs. Next, encoder states, we get it from the array of state h and state c. Next, decoder inputs. We get the input, again almost similar as the encoder where we call the input function, but instead of encoder we give the decoder tokens. Then decoder LSTM, we call the LSTM function and get the latent dim, return sequence equal to true, and return state equal to true. Decoder outputs, comma underscore underscore, we don't need these, so that's why these are underscore underscore, equal to decoder LSTM, decoder inputs, and input state equal to encoder states. Now decoder dense is a dense layer we create here using the dense function by passing it the number of decoder tokens and activation equal to softmax. Decoder outputs, we call the decoder dense function and pass it the decoder output that we get. Then we call the model function and pass it the encoder inputs, decoder inputs in an array, and then the next parameter of decoder outputs. Then we compile the model by calling the compile function. We pass the optimizer as RMS prop and loss function of categorical cross entropy. Then we train the model by calling the fit function and pass it an array of encoder input data, decoder input data, and then pass the decoder target data. Next is the batch size and epochs and validation split. Now save the train model by calling the save. You can also deploy it here. And then finally implement chatbot interaction using the trained model by creating a chatbot response and get the input text in there and return the generated text. Inside this you can pre-process input text, you can do encode input text using the encoder model, generate response using the decoder model, and decode response token into text. This example demonstrates how to implement a simple chatbot using a sequence-to-sequence model architecture with TensorFlow's Keras API. You can further enhance the chatbot's performance by experimenting with different architectures, training strategies, and techniques like attention mechanisms. Additionally, consider integrating the chatbot with an external APIs or services for more advanced functionality.